I'm pretty sure this is the world's first Etch-a-Sketch camera, and it's about to draw my face.
In 24 hours, our Etch-a-Sketch robot needs to be submitted.
Whoa. That's his hand. That's his hand. Welcome back to Every Flavor of Robot. This video is brought to you by Alex's Wallet. If you or a loved one have ever felt empty on the inside, Alex's Wallet knows how you feel. More on them later. Swapno and I have been having a hard time getting one of our recent projects working. We're slowly chipping away at it, but it's a slog. And on a lot of our breaks of debugging this robot, we started this game of who could draw the best circle on an Etch-a-Sketch.
Winner takes all.
Winner takes all?
Winner takes all.
He's pull sharking me. Okay. Left and right. Up and down.
Oh, that's a big circle, Alex. Don't mess it up now.
One of my better ones. Not my best, for sure. But not bad.
Go ahead, take a seat. Oh yeah. That's been the rough right warm up. A little bit of curves there. Okay, back to the zero.
It's not even close.
Saltman, you drew like a lima bean.
Is that what your circles look like?
During one of these breaks, we got a text from our friend Ravi. He was letting us know about a convention called Opensauce. And not to sound like too much of a fangirl, but when I saw the people that are gonna be there, pretty much every YouTuber in science communication and engineering that I look up to, it was a no-brainer. We are going to try so hard to get into this exhibit. Only a slight problem, we don't really know what we're doing, and it's 2 weeks away.
Can't be that bad, right?
We can update the gantry, but I don't know. Ben, what do you think we should do?
What if you guys made a robotic Etch-a-Sketch? I feel like it would be way more interactive than any of these demos.
I feel like that can't be that hard.
Note to self, never say that ever again. Alright, so we're trying to make the coolest Etch-a-Sketch that can be demoed at Opensauce in front of a bunch of people. And we need to be able to draw a line, because every picture is just going to be more or less a bunch of lines. So let's start simple. So here we have a test, starting at one point and going up at 45 degrees, and then trying to come back to the same spot. If the machine is tuned correctly, the lines should perfectly lay on top of each other, and we'll just see one diagonal line. Yeah, I mean, the first test didn't work, but we didn't expect it to. It's the first test. And for you to understand why these tests also didn't work, we have to look at the design and actually explain it. I just threw together this stand that can hold the Etch-a-Sketch. So we're going to 3D print this, and we put the motors on here. These are the cheapest Alibaba $3 motors that I could find online. And we're going to glue a magnet on the back, glue an encoder on the back of this, and all of that is going to be controlled by our little circuit board that we made custom just for robots like this. If you're lost, this diagram captures all three parts of it. We have a motor that we've glued a magnet to. We have a device that can read where the magnet is, called an encoder. And we have a circuit board that makes the motor go. This is the basic building block of a servo. And in engineering terms, we call this a closed-loop controller, because not only do we have control over something, but we have feedback on how that control is doing. So if we go off course, we can see that and fix it, right? Well, a few of you might be in possession of eyeballs and notice that it does not look very fixed. To summarize what we learned through a bunch of tests, I'm going to draw a couple different scenarios here. So we know that what we want is a perfectly straight line, but that means that both the motors need to be perfectly in sync. which we can tune the robot to do across a short distance or tune it for a long distance, but it's hard to get both without case 2 or 3 happening. Let's say in case number 2 that the motor responsible for up and down movement is too aggressive and it goes too fast. We would have like a vertical spike and then it would settle down and the left and right motor would finally finish its goal. What's unfortunate is that on the way back, it would also have a vertical spike first, followed by a left and right movement, and that would create a completely different path. The third case would be the opposite problem. If you have too weak of a controller, then you're never going to reach your set points, and that error is going to build up over the course of the drawing and mess up the whole thing. It's very difficult to have precise control over both the speed and the position of a robot. But we haven't played all of our cards yet. We have a secret tool that Ben's going to help us explain to combat case number 2.
Okay, now Ben, thank you for participating in this study.
Thank you for the opportunity.
So Ben's going to demonstrate what a feed-forward controller does on a robot. In English, a feed-forward control just means predicting what we need to do before we do it. I've blindfolded Ben here and I'm going to hand him 2 different water bottles, one full of water and one empty. Since he's blind and I'm not telling him which one I'm handing him, he effectively doesn't have a feed-forward controller. And now we're going to compare that to just me telling him, hey, this bottle's full of water.
This one is full of water.
So let's draw a line with this new technique and then move on.
That's something. Wow, that looks so violent on camera.
So here's our test after we calibrated our feed-forward controller and tried to draw a square.
The angry square. Ready? Let's do it. Okay. Oh, the vibration that I felt is terrifying. I want safety glasses. Go. It's just teleporting. Oh my Allah. Oh, you done both.
Alright, we're back in Khan Academy mode to explain what the whole square thing was. We're calibrating our feed-forward multiplier. So we know that if we were supposed to move 20 millimeters, and we actually measure 10 millimeters, then that means if our power is equal to our feed-forward multiplier times the distance that we're trying to travel, since it only went half the distance, this gain actually needs to be 2 times as much. Easy peasy. But even though we can go between points and make shapes, there's still a problem. These are all, let's say it together, really lame. And actually, we want to build stuff with the Etch-a-Sketch that's not lame. Like this hot dog robot. We need to be able to convert this into a bunch of XY coordinates to send to the Etch-a-Sketch robot. We might be the first people to run into this particular problem of it being a hot dog, but in general, people have wanted to send things over to machines. So 3D printers and CNC machines and laser cutters and machines like that all use something called G-code, which actually stands for geometry, code, ode, duh. Bleh. So if we could take G-code, we could put anything on the Etch-a-Sketch robot, even this awesome robot hot dog. So Swapnil's adding compatibility for G-code, and then we're going to test it on a square, and then we can move on to the crazy stuff.
As fast as possible.
Here we go.
That's stupid.
That is scary.
Uh-oh.
1.
Oh my god.
Make it stop.
No! That's not very... worst square ever.
Oh, it didn't even home. What? So it was supposed to go back here and then start drawing.
I think something's a little wrong.
Is the robot okay?
I think something's broke. Yeah, so okay, I'm gonna take this to the garage and go over it. Can you do your debugging on the jumping robot since it has the same board?
Yeah, that's a good idea.
Okay. I don't want to be the reason that this project is held up. So I'm just gonna do it tonight. Maybe. I don't think the soldering is fine, but. Oh my god, wait. Oh. Well, that's definitely the problem. This thing is just... it just vibrated off the screws. Okay, well, I bet that's actually 99% of the problem. So that was easy. And now I'm gonna go to sleep.
We have about 1 week and a day until we need to submit the application, and we spent the last 2 days doing really important things. Swapnil wrote some code that can convert an image like this family portrait into an SVG file, and then take that SVG file and turn it into G-code, which you've already seen that we can pass to our Etch-a-Sketch to draw. We can also use the same Wi-Fi connection to send data back to our computer and graph it, which will help us find bugs. Meanwhile, I was putting things back together and adding a little bit more hot glue, and then getting it back to Swapnil so he can keep testing. But we had to take a detour to go stare at the sun, which kind of sucked because something was in the way, but at least work was going so well that we could take a whole day off before we had to get back to work, because now it's portrait time.
Not quite.
This is portrait time.
Oh, that's funny.
Alright, this is portrait time.
It's actually just
Broken. It's actually just broken. We broke it.
Brother, this guy stinks!
But I guess we need to take it apart, see what's wrong with it. Ideally, we can figure out what's wrong and fix it and not have to replace the Etch-a-Sketch. But if we do replace it, we still need to know why it broke. Oh, JK. Oh, just kidding. Oh, no. Oh. Man, normally I last longer than that. Oh, man, God. Ignore the mess.
This is embarrassing. I wouldn't want to show this to anyone on the internet.
Okay, guys, so I made an explanation for this part, but honestly, no one cares. Drum will go... And now, the moment of truth.
A question I've always been wondering since I was like 7.
What's inside the box? Okay. Yeah. What?
Okay. Inside an Etch-a-Sketch is another Etch-a-Sketch. It really is just a cover. So with the trusty butter knife, we're able to take this off.
This part's actually really easy to get off. Set this down over here, and we can see inside the Etch-a-Sketch mechanism. It's 2 rails, and it has this like very thin string that is attached to each knob. We have clearly destroyed that string, and I don't have any intention of replacing it because it looks really hard to do. But we are going to be really careful about this in the future because it is such a fragile little mechanism. If you want a closer look at the mechanism, go check out Kevin E. Davis's video on it. His video is super clear, but we got to keep moving. We were able to get a new Etch-a-Sketch, but we were really scared of breaking it, so we were going through everything and calibrating everything really carefully. We came to the realization that the square test was a lie. Let me explain what I mean by that. We let ourselves believe that if we could complete the square G-code, then any demo that we might want to run at Opensauce might be longer, but it won't be more complicated. Because if we can go in a straight line, and we can go at a slanted line, then can't you make everything? We didn't consider the different speeds that the motors would need to spin, and we mainly just calibrated for really fast movements. Straight lines are fine. And 45-degree lines are okay because that just means that both motors are spinning at as fast as they can basically. But to spin at any other angle than 45 degrees, one of the motors has to be going at a fraction of the speed of the others. And that's where our controller breaks down, so we need to recalibrate. So just to summarize, we have this thing set up for really fast movements, but we actually need to be able to do really slow movements. And after we recalibrate, this is the kind of elite performance that we're able to get out of this machine.
Oh, Drew, West Virginia.
Whoa. Whoa. All right.
And this is bad. It's just not good. Like on a scale of good to like not good, we're all the way over here. I could have just handed the Etch-a-Sketch to Swapnil if I wanted drawings like this. To remedy this, we need to talk about our motors. Now some of you are definitely thinking, why didn't you use stepper motors? And a lot of you are also thinking, what is a stepper motor? Now, I'm not going to get into all of the different nitty-gritty details of the architecture of motors, but in summary, there is a type of motor called a stepper motor that really excels at really high precision movements like this, and these are commonly used in plotting type robotic devices because it simplifies a lot of the controls that you would need to do to get these movements. Compare that to the motors that we chose, which are built for drones and specialize in spinning really fast and being really lightweight. Now, most of you might be assuming that I'm bringing this up because we're going to switch to stepper motors, but actually we're not. For the same reason I'm not going to replace my morning coffee with prune juice and a laxative. It might take me to the same destination, but it's not accomplishing all of my goals. The goal of my morning coffee is to make my brain vibrate a little bit faster, and the goal of this project using drone motors is to challenge our engineering and controls. Okay, let's get back on topic. What are we doing to fix the problem then? Well, if these motors want to spin fast, then let's let them spin fast. While y'all were busy listening to a rant and some poop jokes, our engineer Tom was designing us an entire new chassis for the Etch-a-Sketch that has a belt drive system built into it. And by gearing down the motors, we can get much higher resolution drawings done. And since we were nowhere near the top speed of our motors yet, it's free. So now that we have an actual truthful calibration script, we can get back onto making a demo for Opensauce that's going to let us get into the exhibitions.
I'm gonna restart everything. Put this over here.
Alright, so now that everything's calibrated and it can run the G-code and actually follow the commands, we're ready to tackle the family portrait again.
Fascinating.
Pretty sure we scaled that one incorrectly, and that's why it was small and in the top right corner.
You ready again?
I'm ready.
Here we go.
We haven't started increasing the motor speed yet, so I'm going to go ahead and jump towards the end of this test to let you see.
I think it's working.
I think it is.
If we got rid of all these collinear points,
Yeah.
By collinear points, I mean that you can kind of see that the Etch-a-Sketch is drawing back and forth over and over again, even though there's already a line there. Technically, the points are probably different coordinates, but the resolution is finer than we can actually draw, so we should be removing them. But first we have to figure out why this picture doesn't look anything like the portrait that we took.
Okay, well,
something's going on and squashing all of the things to the limits.
yeah.
Now, here's my question. Does this look like any portion of the... Can you pull up the G-code?
Yeah.
That's
awesome.
That's his hand. That's his hand.
Whoa, dude. Oh, okay. Let me fix this. Okay.
So it's gonna work.
No.
It's gonna work.
Oh my goodness, we finally have confirmation that this project is going to work, and now we just have to finish it in 5 days. But honestly, it's still not in a great spot.
So that's a window.
I can see the window.
That's the lantern.
Yeah,
That's a hand.
I see that.
Like, this is a great milestone, but it's just not ready for a demo in front of hundreds and hundreds of people.
Way faster.
It's really fast. In 24 hours, our Etch-a-Sketch robot needs to be submitted. Godspeed.
Okay, a ton has happened in the past 4 days, and we are getting ready for the application demo to Opensauce. We got a camera hooked up and uploading images to our computer that can process it. I also decided to add some more gear reduction so we can have better controls on the drawings. But they are so stuck to this build plate. What, you never seen a hammer drill? What's important is that the gears fit on the Etch-a-Sketch, they seem pretty good, and it's able to go a lot faster. Wow, it's zooming. Now, if only we could figure out why everything's happening upside down. Also, these gears feel like way more dangerous than the belts, so we're gonna put some covers on them, but I also think they look really cool, so we're gonna make them out of acrylic. We have this really cheap CO2 laser, that we keep in our garage, and I love an excuse to use this thing. It cuts through acrylic in like 25 bajillion passes, but hey, it gets the job done. What can I say? We are on our final push to get this demo ready. We have 16 hours left. It's probably going to be a really late night, but we need to get these pictures drawing fast and well. The problem is, there is one piece of this design that we haven't even talked about yet, but it is definitely like the final boss. So I told you all that we can take an image and we can convert it through the things and end up with G-code. And that's great, we can run that G-code. However, it's like 50,000 lines. We need it to be like 1,000. And so we've been working on optimizing the G-code. However, our optimization needs to be fast. We can't have everyone waiting around for 15-20 minutes while their picture is being processed. And above all else, we need to make sure that the Etch-a-Sketch drawing comes out good. So what are you gonna do about it? Well, we have two secret weapons that we've been working on. The first one is called Voodoo. Cartoonify, this really cool GitHub repo that we found, and they had an amazing demo on neural style transfer. Basically being able to take an image and make it look as if it was painted or drawn in a specific artistic style. This is an automatic cheat code for taking an image and turning it into something simple enough that we can draw in the Etch-a-Sketch. Because if you just take a normal picture and you ask a computer to find all the edges on it, you get this really messy result most of the time. You can try to clean it up and stylize it first, but it's hard to remove noise without destroying the features of the picture, which is why I call the style transfer stuff magic, because it lets us keep the cowboy hat and all four legs of the dog. Now the second secret weapon is some weird math, computer science stuff commonly referred to as the traveling salesman problem, which you can go read about on your own, but it basically lets us choose the shortest path, which means a faster drawing. And we can also use it to travel back on lines we've already drawn to clean up stuff like this and turn it into this. Anyways, I know you're thinking, enough nerd talk, Etch-a-Sketch man, show me the portrait. And I'm happy to oblige.
No way.
And now that we've achieved photorealism, we can move on to the Opensauce demo.
Yeah, identified.
We got accepted. Yeah. Check the email. Oh, I don't know, I just saw the email. Said accepted. We're gonna go.
Yeah.
We did it.
Yeah.
Ladies and gentlemen, the robot isn't even functional right now.
Oh, there's a Discord for the exhibitors. Oh,
I'm in the normal Discord, but I'm not in the.
Time to book the most expensive flights I've ever booked.
Oh, we gotta buy some plane tickets.
if you're looking at this, William Osmond, can you?
Alright, we still have a bunch more demos that I'm going to show you guys, and I'm not even going to stop showing them on the screen. But this one goes out to a very special someone. Or actually it goes out to a very special 600 people. That's how many people have subscribed to the channel at the time that I'm editing this video. I don't even know what to say other than just thank you. This is so fun to be able to share these robots with y'all, and I hope that we can keep sharing many more types of robots, dare I say every flavor of robot. And yeah, I just wanted to say that I really appreciate you, whether you've been here since day one like my mom, or we just stumbled into your feed and you decided to click subscribe very recently. Also, check out this 600 subs sign is actually made of a bunch of little robots.
So cool.
And one more targeted demo. AI Robin, our one and only Patreon subscriber. Hey man, that means the world. Thank you so much. Our Patreon is where we keep all of our engineering notes as we're building these robots, and we keep that in the free tier so that anyone can see the engineering process. But if you believe in supporting us to build robots and make open source contributions and help educate the robotics community, please consider subscribing to our Patreon as well. Anyways, let's get back to the Etch-a-Sketch machine drawing crazy stuff.
Oh, okay. Oh, I'm so happy.
Yeah. It's on. The pressure's on.
We got these pictures from our Discord members. They were fun to draw, but some of them were gross. Like this one. See if you can guess what this one is. Honestly, this is probably the hardest one. I wish it turned out a little bit better than it did, but it was just a complicated image.
Oh. How long ago did they send me an email?
It was 11:24 a.m. 11 minutes ago.
This one didn't turn out super cleanly either, but I think it's just hilarious. If you've watched this far into the video, please consider subscribing and please consider sharing this video with anyone that you think would enjoy getting into robotics or seeing a robot camera Etch-a-Sketch. This one's unique because it was a drawing on a whiteboard that my friends came over to my house and drew, and then we took a picture of it with the Etch-a-Sketch camera, and I just thought it was like such a good replication of the drawing. It's just phenomenal. It's a really cool little demo. That is just so wonderful. It's so good at capturing whiteboard drawings. Matteo made such a beautiful piece of art here today. Okay, thanks for watching. Goodbye. See you, Opensauce.
It's pretty good.
Okay, you can tell what it is.
You can definitely tell what it is.
The text is not.